Hi students, in the last video, we discussed the Bohr's models, that is Dalton's atomic model, Thomson's model, and Rutherford atomic model. So those models gives some information about the structure of atom, the size of the nucleus, that is where that alpha particle is retraces back. That distance is known as from the nucleus is called as a distance of closest approach. So that closest approach distance is also taken or considering as the radius of the nucleus, which is in the order of fermion. That is a 10 power minus 14 meters. One Fermi is 10 power minus 14 or 15, generally minus 15. But exactly if you are calculated or you can be observed, that is 1.4 into 10 power minus 14 is the radius of nucleus. So that we can get information related to the size of the nucleus and also some information about the atomic structure given by the Rutherford alpha scattering experiment, right? And in that experiment, the Rutherford is unable to explain about, so electrons are revolving around the nucleus in different allowed orbital paths, but when they are revolving is not explained about how that energy is remains constant. That energy of any moving particle is always radiates or loses its energy. Once that electrons which are revolving around the nucleus, they will lose their energy, they will follow say a spiral path, and at the end that electrons are getting into the nucleus, that is collapsing into the nucleus. But that is not happening. So electrons are continuously revolving around the nucleus, they are not getting into the nucleus, right? So because of that, that is the one defect of Rutherford atomic model. And one more is, once these electrons are revolving around the nucleus, they will be emitting the energy or radiations continuously. That means we need to get the continuous spectrum from the atoms. But practically as of now, whatever we studied about the spectrum emitted by the atom is a line spectrum we can get. So that is also one more observation of the defect that is not explained by the Rutherford, right? So to overcome these, the Bohr is taken or considered or given some postulates, that is statements considered to explain about atomic structure. And following the remaining factors given by the Rutherford are, that is electrons are revolving around the nucleus, like how the planets are revolving around the sun, that is solar system, like that also here it is following, and is considered some postulates, some formulas, some statements to study about the atomic structure. So they are nothing but you can be having Bohr's postulates. So what are the Bohr's postulates we have? That is first one. Whenever these electrons are revolving around the nucleus, they are not to lose their energy. They are not radiating their energy. They are just revolving without radiating. And we are calling that orbital paths are nothing but stationary orbits. Stationary orbits. That means here the first point given by these stationary orbits. Stationary orbits. That means the orbital paths followed by the electrons around the nucleus, they are not emitting, not losing their energy. Even though they are revolving, the energy remains constant. That is not losing. So we can call that orbital paths followed by the electrons around the nucleus are known as stationary orbits, right? So that is we can be observed here. When they are revolving in the circular orbital paths, so that can be experienced a force. That force is a centripetal force. That is because of attraction between electrons and a nucleus. That centripetal force is equal to electrostatic force between these two charges, that is electron and nucleus. So that is here with respect to this, when these electrons are moving in circular paths, this is the nucleus having the charges plus Ze, and here electron is moving with velocity e, then you can be observed with a radius of r. then this force attracted towards the center, that is centripetal force, is nothing but it is the electrostatic force between the two charges. So that you can be observed here is 1 upon 4 pi epsilon naught ZE into E upon R square is equal to mv square by R. So this centripetal force acting on this electron towards the nucleus is given by this equation we have. So this is 1 by 4 pi epsilon naught. You can write this k, some constant, 9 into 10 power 9 you have. So this is k ZE square by R square is equal to mv square by R. So this is the equation you can use for just resolving or calculating the radius or velocities of electrons in different orbits. So we can apply or we can use. So this is the first postulate given by the Boar. And the second one, whenever these electrons are making in circular paths with different radius, with different velocities, and there you can be observed they are moving on circular paths, they are changing their angles, angular displacement, angular velocity, angular acceleration, all these observations you can be having. But here angular momentum of a revolving electron, the angular momentum of a revolving electron is given some values calculation, that is second postulate. So here the angular momentum of a revolving electron around the nucleus according to Boar is you can be having integral multiple of h cut, that is h by 2 pi. So here the angular momentum of electron in nth orbit is equal to integral multiple of h cut. H cut is nothing but h by 2 pi. So here the angular momentum of electron in nth orbit can also be written is you can be having I into omega is also you can write angular momentum, and also you can write mvr, and also you can write this is equal to n h cut. H cut is nothing but h upon 2 pi. So this is you can be having where this n is, you can be having here integral multiple. It is starting from 1, that is you can be observed here where n is equal to 1, 2, 3, 4 and so on. Right. Now this is what it is given by the second postulate with related to that electron having the angular momentum is given by this is the equation. Right. The angular momentum of an electron which is revolving in nth orbit is given by this equation we have. And third one, when these electrons are revolving in different radius around the nucleus, can we possess some amount of energy? So that energy is the combination of both kinetic and potential. Kinetic energy by virtue of its motion in that particular orbital path, and potential energy due to the virtue of its attraction is existing between that electron and the nucleus. So here electrons possess energy. Electrons possess energy. That is you can be having E is equal to kinetic energy and potential energy. The sum of both these energies you can be get the total energy of electron in any orbit. Okay, that you can be determined, right? So this kinetic energy is due to the virtue of its motion in that particular orbital path, and also you can possess the potential energy by virtue of its attraction force between the electrons and nucleus, right? So this is the third postulate given by the Boar. And next one, the fourth one. Here, whenever the electrons are made transitions where they are moving from one orbit to another orbit, maybe it is from lower state to higher energy state or higher energy to lower energy state, when they are made transition, there is some amount of energy can be emitted or radiated or maybe absorbed. So that amount of energy is the difference in the energy of the electrons present in that particular states. So that is here the energy can be emitted or may be absorbed by that particular atom only takes place when electrons make transitions, maybe from lower energy to higher energy, or when it is making the lower energy to higher energy, it can be absorbed. When it is moving from higher energy to lower energy, then it can be radiates. Okay, what is that amount of energy? So that amount of energy is given as the difference between the energy of two states which are possessed by that electrons where that transition made. So that is here you can be observed the difference in the energy, that is delta E is equal to E2 minus E1. The difference in the energy is nothing but this energy may be radiated or may be absorbs. Maybe it is emitted or absorbs. So depends upon where to where that electron made a transition. So that is you can be observed to be here. This is also equal to h nu. That is the amount of frequency. H is the Planck's constant. U is the frequency of radiation. So this frequency of radiation may be how much it can be absorbed when it is made transition from lower to higher. And when it is made from higher to lower, the transition of electron, there you can be observed to be having here it is that energy is emitted. It can be gives out, radiated out, right? So this is equal to, you can write Hc by lambda. So these are equations you can be observed. Correct? So these are the 4 points. First you have to remember about the considerations made by that Bohr in order to study further about the atomic structure, right? About the atom, that is how the electrons are present in different energy states. When they are moving from one energy level to another energy level, how that energy can be radiated or absorbed, or what is its angular momentum or time period, all these radius, velocity, everything we can be calculated. So we have to know about these 4 points related to these Bohr's postulates, right? Okay. Now this is the consideration made by the Bohr before making into different studies further about atomic structure, that is radius of electron, that we can be calculated. What is the radius of an electron which is revolving in the nth orbit, or what is the velocity, and what is its time period to complete that circular path or angular path. So all these we can be calculated, observed, and what factors it will depends. So that part we can be seen now. Correct? So now we can go for equations, that is radius. What is the equation for radius of an electron revolving in nth orbit for any atom? Right? Now here equation of radius, that is radius of electron in nth orbit. Radius of an electron which is revolving in electron in nth orbit. Nth orbit. Now consider an electron having the mass m and moving with velocity in that orbital path is Vn and radius is Rn. Right? So that we can be observed to be having the consideration. Let it be, if you are considered here, an electron is revolving in an orbital path. So this is the nucleus we have, it is plus Ze charge. So here to here the radius is Rn, and here that electron is moving with velocity is Vn. So electron here we have this E, right? So this is what you can be considered here. So what is the equation for this radius? So that we can be write or calculate. Okay. Now you can be see here. Apply the postulates given by the Bohr in order to study the structure of atom. So the first postulate itself we can be having some information about there is centripetal force is equal to the electrostatic force between that electron and the nucleus. Right? So I can write here from first postulate, from Bohr's first postulate. Okay, what you can write? You can write this one is K 1 by 4 pi epsilon I have written K into Ze into E upon Rn square is equal to mVn square by R, that is Rn. Right? So this is the equation you can be get from Bohr's first postulate itself. Right? Now in this you just observe or rearrange. One of the Rn is made to be cancelled. Right? And in this you can write what is Rn by using this. That is, you can be observed to be having here this mVn square you write here, Rn to this side. Then you can this can be written as here is Rn is equal to, I can put this one is Kz E square upon mVn Vn square. Make it this equation 1. So here we written the equation for Rn, but in terms of Vn. Vn you write it in terms of the constant values that is known for us. So what are the constant values? So now you can write it is again you can use again from Boar's second postulate or Boar's postulate. Okay, that is you can be having here angular momentum, that is mvn Rn is equal to mvn Rn is equal to nh upon 2 pi. From this you write the equation for what is Vn. So Vn is equal to what you know it is nh upon 2 pi. Here it is m into Rn, 2 pi m into Rn. So make it this is the second equation. Now you put the second equation in this first equation in place of this Vn. You can eliminate that Vn and we can get the equation for Rn. Now I am writing here from 1 and 2 equations we can be get here is Rn is equal to k z e square upon m into Vn square. So make it this one to be square and put it here. That is you can write this one is n square h square into here you can write this will be 4 pi square m square Rn square. So this is after substituting the second equation in the first equation you can get this one. Now rearrange the terms in this, that is here it is one of the m is cancelled, right, and here this Rn is cancelled. So we required Rn, all these values to put this side. That is what I can write this one is here Rn is equal to, I will bring this one all to this side. Here Rn is there. Now I am writing this one is, this will be moves up, that I can write it is what you can be observed here h square upon this total value. The total value is given by here is you have here that is 4 pi square and here it is you can be observed k e square m is there, here z, and here n square is there. You can write it is n square upon z. So this is what is the equation can be written for Rn. See this Rn is given by h square upon 4 pi square k square m into n square by z. Right. And now you can be observed this equation that is already written here is this is 4 pi square m square Rn square k n square h square, right. So now you got this equation. Now in this you can be observed h is constant, 4 constant, pi constant, k constant, 1 by 4 pi epsilon naught, 9 into 10 power 9. E constant, charge of electron, mass of electron. So if you put all these values, then you can be get the equation of these constant values, and when you simplify, this can be further you can write Rn is equal to 0.529 into n square upon z. It is in angstrom units. The value of radius is calculated and given as here it is how much. This is the equation you can be having the calculation after substituting the constant values. So after substituting these all constant values, this equation will be made into 0.529 into n square by z angstrom units. So in this, if you observe, this value can be further you can write it is simply that is Rn is equal to 0.53 n square upon z in angstrom units. So this is the equation for the radius, right. If it is goes for hydrogen like atoms where z is equal to 1, there you can be observed here if z is equal to 1 for hydrogen H2 atoms. There, what is the radius of that electron which is revolving in the first orbit? There you can write here is n is equal to 1 you put, you can get it is R1 is equal to how much you can get? It will become as here 0.53 into n square by z. N is 1, z is 1. So 1 square by 1, you will get 1 only. So that is angstrom units. That means the radius of electron in the first orbit of hydrogen atom is 1 by how much it is? 0.53 angstrom units. So this is the first value. If you have taken n is equal to 2, what is the radius of the electron in the second orbit of hydrogen atom? So n is equal to 2, that is R2 is equal to, you can make this one to be 0.53 into 2 square by 1, it is a 4 angstroms. So this will become as here 12, it will be 20, 21, so it is 2.12 angstroms. So like this you can calculate any number of the radius of electron anywhere they are locating depends upon the position of that electron, right? So on you can write if it is n is equal to 10, then what is the R10, the radius of electron in the 10th orbit for the hydrogen atom, that will become as here 100, it will come, that is how much it is 53 angstroms, you can figure it. So like this you can calculate the radius of an electron in any atom, that is depends on which factor, that depends on where it is locating, where it is revolving, and what is the atomic number of, that is Z value required, what is the atomic number of particular element, hydrogen or copper or whatever it is, Z value and N value. Based on that you can be having this information. So Rn is proportional to n square by Z. So this is important, you have to make remember, right? So Rn is proportional to Z square, n square by Z. That is we can be having. So in this way we can be calculate what is the distance or the radius of an electron which is locating in any orbit. With respect to this equation we can be calculate, right? So in this way we can be get one of the equation, that is radius. So radius of an electron in nth orbit, that is we can be get. Okay. Now similarly we can find out what is the velocity of electron in that nth orbit. Vn we want to write. See this, already we required which one, Vn, second equation is there, but Rn value already we have here based in terms of this Rn value is there. So this Rn value put here in place of this Rn, right? So here this value Rn value, if you are substituting in place of this second equation as where we have the Rn, there you can get replace this Rn and you can get the Vn, that is velocity of electron in the nth orbit can be determined, correct? So that is here I am taking this is the third equation. Then you can be observed, substitute the third equation in second. There you can get the equation for velocity of electron in nth orbit. So that is, so I just remove this part, or I can remove that part and substituting the third equation in second. Then you can find out the equation for velocity of an electron in nth orbit, right? So that we can be right now. So here, what is the velocity? So that is, I can be see or I can be observed to be calculated here. Okay. Now here velocity of electron I want to calculate. Velocity of electron in nth orbit. So what is the velocity of electron which is revolving in the nth orbit? So that is given by here is substitute the third equation in second, or you can write here from 2 and 3 equations. From 2 and 3 equations you can write here, that is what you can get here, Vn, velocity of electron in nth orbit is equal to nh upon 2 pi m into 1 by Rn. So Rn is this 1 by Rn, make it reciprocal. That means what I can write this one is you can write here 4 pi square k e square m by h square into n square by z. So here, no, this will be made reciprocal, that is z by n square, z upon n square. So now just simplify the terms. Here h, one h, here n, this n is cancelled, and here this m cancelled, right? Now in this, any other cancellation you have here, one of the pi is cancelled, 2 is cancelled. Now what are the remaining terms you just write here? Velocity of electron in nth orbit is given by, here it is 2 pi k E square. So these are cancelled, right? H is there upon H into what we have here, Z upon N. So this is the equation you got. So this is the equation you can be absolutely having. I can write it as a fourth equation. So velocity of electron in nth orbit is given by this formula we got. Now if you are again substituting this constant values k 9 into 10 power 9, E 1.6 into 10 power minus 19 whole square, H 6.62 into 10 power minus 34 joule second. So if you substitute all these constant values in this equation, again you can get this one and you can write in terms of comparison with velocity of light. That is here I can write this one is Vn is equal to C upon 137 into Z by N, it is in meter per second. So the value for which one is velocity of electron in nth orbit is given by, so this is the equation we have, C upon 137 Z by N meter per second, where C is velocity of light in air medium, in vacuum. So right, where you can be observed here, C is, what is that? Velocity of light in free space or in air medium. So this is the equation, and from this what you get, Vn is proportional to Z by N. So here you see this velocity is it is any mass? No. So the velocity of electron in any orbit is independent of mass. The velocity of any particle revolving around the nucleus, that is electron, which is independent of mass of electron, right? So it is only depends upon where which orbit it is rotating and what it is, its atomic number. Depends upon this N and Z, you can be having this velocity of electron can be modified or changes. So that is, you can be observed here from this equation, Vn proportional to what do you have here, Z by N. So velocity of any electron in nth orbit or it is depends or it is inversely proportional to order of the orbit. That is Vn is proportional to Z upon N. So this is the equation for velocity of electron in nth orbit. In terms of velocity of light, we have this one, and how it is related to the velocity of light. Velocity of these electrons is independent of mass of that electron, and it is changes or it is depends on order or the orbit where it is revolving. That is, we have this relation Vn proportional to Z by N. So we calculated what is the radius. We calculated what is velocity. Right? We got these 3 and 4 equations. By using these 3 and 4 equations, you can find out what is the angular velocity and what is the time period. So those also we can be right. First, I will make this part, that is the second, that is third and fourth equations I will compare, because omega is equal to V by R. We know that here velocity of electron in nth orbit. We know the radius of the electron in nth orbit. If you divide this Vn by Rn, you can get omega n. That is nothing but it is the angular velocity of the electron in that nth orbit can be determined. How it is related with respect to this Z and N, that is atomic number and the order of the electron, that is orbit where it is revolving. With respect to N and Z, how that angular velocity depends, or how the time period of that electron also depends. So that we can see now. Just I will remove this part and I will comparing this or observing here the angular velocity. Now I will go for angular velocity and time period of electron in nth orbit. So that is here the two equations we see. One is Rn proportional to n square by z and Vn proportional to z by n. So these two we already got here information. Now we are going to discuss or we are going to see angular velocity. So now you can go for angular velocity and time period. Angular velocity and time period of electron in nth orbital. Right. So now what is the angular velocity? Okay. Now you can write here by definition of angular velocity. By definition of angular velocity, we can write here omega n is equal to Vn upon So here we have the Vn is there, here we have the Rn is there. So make this simplification, this one divided by this, then what you can get? That is Vn, you can be having the total part. I am writing the remaining part, whatever the constant values are there, I will put as it is, just what you can be observed to be having here it is. Okay, right? And now you can be write or you can be see this. Here you can be observed to be write. This one is r square, no, this is m square is there. So one of the m is there, you can be having here m. So it is m also you can be having, okay, calculate that. So I can write now Vn. So omega n is equal to, I can make this calculation part, I will put all our constants only related to this n square by z and here z by n. So I can write z by n and this will be make it reciprocal. So then what you can write here, this total constant I am writing this omega naught. And remaining part what you have Vn by Rn. Vn is nothing but I can write here z by n and divided by this n square by z. It will make it reciprocal. What do you get? Z square by n cube. It will come as z square by n cube. So this is the equation for angular velocity of electron in nth orbit, how it is related to z and n. So this is the equation. Similarly, omega n you know, you can write this one also, it is 2 pi by Tn, time period of electron in nth orbit. So now I can write this is omega naught into z square by n cube. I want to this one, that is you can be observed Tn. So I can write here is Tn, time period of electron in nth orbit is given by it is 2 pi upon, this will become 2 pi upon omega naught and it is n cube by z square. So this is the other observation you can be having here. Again here in this omega n and Tn both are independent of mass, but whereas here this velocity is depends upon mass is there, okay, mass is present, but electron this is what you can be calculated. This electron mass is substituted, you can get this one. But if it is mass is changes, use this equation for calculating the velocity of that particle, right? So now you can be observed these omega n and Tn. So here already I written velocity. So now I can write here it is omega n, it is proportional to z square by n cube, or Tn proportional to n cube by z square. So these are the different points you have to remember. So this omega n and Tn are independent of mass of the electron. It does not depend on mass of the electron. It is independent of mass of electron. So in this the important information we need to remember, or you have to observe. These are very important. This one, these four. That is radius of electron n square by z, velocity of electron z by n, and omega n angular velocity of electron it is z square by n cube. And one more is there, that is a time period of electron in nth orbit proportional to n cube by again z square, right? So these are the four relations today we discuss related to this electron, its a radius, its a velocity, its angular velocity, its a time period. What are the equations we have and how it is related with this radius, that is in which radius it is revolving, where it will be having the, what is the velocity, what is the angular velocity, what is the time period. So all this we can be derived and we have this information, right? So today's class we can sign off.